chunking, embedding, vector DBs, RAGs, multimodal, prompt engineering. You keep hearing all of these terms, all of these jargons whenever someone talks about AI, and you are wondering, what does that even mean? Today, I'm going to explain these terms in very, very simple words for you. So if you are planning to build your own AI product, you can understand what concerns you and what doesn't. And if someone is just using these terms, using these technical jargons to make themselves sound cool. Let's start with chunking. So large language models are very, very good at summarizing the information or spitting out the information in a more human readable format, in a human like text. Now machines don't actually understand what that text means, okay? So they have to convert that text into mathematical form, right? Because machines only understand maths. Now to convert a text based string into maths, they first want to create different small segments of that text and then store that text in a huge index. We will come to that later. But machines convert that huge amount of text into small chunks, into small segments. Let's say if there is a sentence called "This is AI," then the machine might decide to create chunks which includes THIS and I, and then S and AI into one chunk. So it's not necessary that they create one chunk for each word, or if they create one chunk for each line. There are different chunking techniques called semantic chunking, agentic chunking, and a lot of those techniques. So based on the chunking technique, it decides to create different chunks of data so it can be stored in something which I will come to later on. So that's chunking, nothing complex. There is a huge amount of data, and if AI needs to process that data, if AI needs to understand that data, it needs to convert that into mathematical numbers, mathematical formats. Okay. And for that, it converts a long text into small chunks and then stores that somewhere. Now, embeddings. What is an embedding? Now, we have just learned in the previous part that machine creates those chunks. Now, those chunks are still strings, text. Now, machine doesn't understand text. Machine understands numbers. Okay. So now machine converts that text into numbers. And whenever machine converts a string of text, a chunk of text into a string of numbers, we call that a vector. Okay. So a string of text converted into a string of numbers, for the machine to be able to interpret it, we have to convert that into numbers based vectors. So it's basically an array, basically a list of numbers that machine can understand. Then comes the third part, vector DB. So by now it should be obvious. We have created the vectors in the previous part. Vector DB is something that can efficiently store those vectors into itself. So whenever we query something with some other vectors, whenever we apply different filters, whenever we make a search query, the vector DB can effectively find similarity from the initial search query across the data that is being placed in the vector database. To understand vector DB, you have to understand the concept of similarity search. All of those AI chatbots that you see these days run on the principle of similarity search. We basically just create a whole index and then we convert those chunks into vectors and then we store those vectors into a huge database. Now, how do we verify, or how do AI return the relevant data if we are asking the question in some different words? Let's say if the AI already knows about swimming pools, if there is a lot of data about swimming pools, about the location of swimming pools in New York, maybe in the database, then how does AI know? How do we query the right words so those words exist in the database? That is not possible, because someone might use some totally different set of words which are not in the original text as it is. So for that, we have to understand similarity search. So in order to find the relevant content based on user's query in the data that we have to find similarity, and that similarity can only be found with the help of vectors. Because remember, machines don't understand English, they don't understand any language, they only understand numbers. Machines can understand that 5 is closer to 2 than it is closer to 20. Okay. So they can find similarity, they can find how close something is to the required data. to their required value. So that is where similarity search comes in. So vector DBs are used so we can store those vectors, and then when a user query comes, we convert the user query into vectors as well. We pass that query into the vector DB, and then whatever result we get out of the vector DB, we send that to LLMs, and then that is processed. We will come to that later on. Now comes the part that summarizes all of it, RAGs, retrieval augmented generation. Now, RAG is a bigger and wider concept that includes chunking, embedding vector DBs and AI into it. So you create the chunks, you convert them into vectors, you store them into vector DBs. User comes in and writes a query. You convert user's query into a set of vectors, and then you pass those vectors into the vector DB to find similar content. Now, once we get set of chunks that are similar to the user's query, we pass those set of chunks to the AI, and now AI responds based on the chunks we have passed by using the chunks as the context of the AI query. And then it responds in a more human like fashion. All of that happens behind the scenes. So we never see how all of that happens from our standpoint. We just ask a question to the AI and AI responds effectively. But behind the scene, this is the whole process that happens. And this is called RAGs. If you ever want to build a system where you have a huge set of data and you want to run text based queries across that data, you want to extract meaning across that data, you want to take actions based on the changes that happen in your data, then RAGs are the solution for you. Moving on to the next part, multimodal. Now, multimodal models are the ones that can process different kinds of information, visual, text, and audio. So let's say if there is an AI that you can point your camera to anywhere, and then you ask about what the AI sees, and then you keep asking the questions, and the AI responds based on where you are, based on what the AI sees. That means AI can process your text based information, your voice information, and the visual information that is available to the AI. So this is called multimodal, that AI can process multiple kinds of information, multiple kinds of mediums of information in the single query. Now coming to prompt engineering, the term that people started using as soon as ChatGPT launched, as soon as generative AI began rising in 2023. So with all of these LLMs, it's very easy to interact with them, right? You just ask anything in normal human like manner. You just write your English queries or maybe queries in other languages as well, and then it responds magically. You don't even have to select any options, you just ask and it responds. Now when generative AI began rising, people started observing that depending on how you ask the question, the answer changes. So if you define some rules in the prompts, and prompt is the message, prompt is just the message that you send to the AI. So people started observing that if you define some rules in the initial message in the prompt, then the AI tries to follow those rules. If you define some limits, if you ask the AI not to do something, it actually follows those rules. There are ways people try to sneak away and still make the AI do things it's not programmed to do or it's not allowed to do. But you can stop a lot of those things from happening by properly doing some prompt engineering. And prompt engineering is just telling the AI in a human like fashion that please don't do it, please do this in a specific format, and most of the time AI follows that. There are a lot of frameworks that make it a lot easier to write these prompts, write guarding prompts, like LangChain provides some wrappers, and there are a lot of other boilerplates as well. Now the final one, which is very popular these days, and I'm planning to make a detailed video about it, but let me just give you guys a very brief overview about it over here. Agentic AI. Now what is agentic AI? Agentic AI is simply an AI that can perform action, that can make decisions, that can set goals for itself. You add some capabilities to that AI. Let's say you are creating an AI that can replace project managers. So it can automatically assess the chats that are happening in a Slack channel. It can automatically create tickets in a Jira dashboard. It can automatically ping the team members in Slack if someone has not responded to their assigned Jira ticket in the 3 days. And even if they have not responded after 3 days, it can drop them a WhatsApp message. So you define a goal in the AI, you assign a set of capabilities, you have to implement those capabilities inside the AI, and then you let the AI run on its own. So you don't even have to prompt it. The AI just keeps running on its own, perform the action unless and until its goal is met. So agentic AI can keep running on its own. You don't even have to prompt it, and it keeps running unless and until its goal is met. I'm planning to make a more detailed one about it and go more deep dive into the technical details of it. So wait for that video and let me know if that is something you guys really want to hear from me, and I will try to make it quicker. So hope you guys enjoyed this different kind of informative video. I wanted to record this so I can explain these very simple terms to people who want to get into AI but are still afraid because of these technical jargons, especially RAGs. People search about this on Google and it says retrieval augmented generation, and then they close the tab. They are like, okay, this is not something for us. It's definitely for you. Everyone can jump into it if you guys just stick to it for long enough. You will be able to see some results and you will be able to build your own AI apps. My name is Hashir Baig. I'm a software engineer turned founder. I have a team of engineers and designers. If you guys like to work with me, if you have an AI idea that you want to discuss with me and need my consultation, drop me a message on LinkedIn. If you like videos like this and if you have some suggestions of what kind of videos we should work on, then drop your suggestions in the comments down below and we will try to make that content as well. Thank you.